Hello and welcome to the next lecture. Generating 3D terrain models. One of the most powerful outputs created from drone survey data is the 3D terrain model. These models provide a detailed three-dimensional representation of the landscape, allowing professionals to visualize and analyze the shape, elevation, and structure of the terrain. Let's explore how these models are generated from drone data. What is a 3D terrain model? A 3D terrain model is a digital representation of the land surface that shows elevation changes and terrain features in three dimensions. Unlike flat aerial images, a 3D terrain model allows user to view the landscape from different angles and better understand the height and slope of the land. These models are typically created using elevation data derived from photogrammetry or LiDAR surveys. 3D terrain models are widely used in industries such as construction, mining, agriculture, infrastructure planning, and environmental monitoring. Step 1. Collecting aerial images. The process begins with a drone survey flight. During the mission, the drone captures high resolution overlapping images across the entire survey area. These images contain the visual information needed to reconstruct the terrain. Proper flight planning ensures that the images have sufficient overlap and coverage. Step 2. Image processing and alignment. Once the images are uploaded in photogrammetry software, the software begins analyzing the images and identifying common points between overlapping photographs. By comparing these shared points, the software calculates the three-dimensional position of each feature. This process generates a point cloud which represents the structure of the terrain using millions of data points. Step 3. Creating the surface model. After the point cloud is generated, the software converts the point cloud into a digital surface model. The DSM represents the elevation of everything visible in the survey area, including terrain, buildings, and vegetation. If the goal is to model only the land surface, the data can be filtered to create a digital terrain model, also known as DTM, that removes objects such as trees and structures. Step 4. Building the 3D terrain mesh. Next, the elevation data is used to generate a 3D mesh model. This mesh connects nearby elevation points to form a continuous surface that represents the terrain. The result is a detailed three-dimensional representation of hills, valleys, slopes, and other land features. Step 5. Visualization and analysis. Once the terrain model is created, it can be visualized from multiple perspectives. User can rotate, zoom, and analyze the terrain model to better understand land elevation, slope gradients, and surface characteristics. These models are extremely useful for tasks such as planning construction projects, studying drainage and water flow, designing roads and infrastructure, monitoring land changes over time, analyzing mining excavation areas. Advantages of 3D terrain models. 3D terrain models provide a much clearer understanding of the landscape compared to traditional maps. They allow professionals to visualize complex terrain, analyze elevation patterns, and perform accurate measurements directly from digital data. Because drone surveys can capture large areas quickly, generating terrain models has become faster and more efficient than traditional surveying methods. Final thoughts. Generating 3D terrain models is a key part of the drone surveying workflow. By combining aerial imagery, photogrammetry, and elevation analysis, drone surveyors can create highly detailed digital representations of real world landscapes. These models play a crucial role in modern mapping, engineering, and environmental analysis. With this lecture, you now have a complete understanding of how drone survey data is transformed into powerful mapping products used across many industries. Thank you and see you in the next lecture.